A very good morning, friends. Welcome to Unacademy. So, how are you? कैसे हो आप लोग? Please confirm the audio video part. Good morning, Ayush. Good morning, Harshit. Himanshu. Harshit, good morning. अरे क्या शर्मा शर्मा की बात हो रही है शर्माने की. चलो ओके स्टार्ट करते हैं. आज थोड़ा लेट हो गया, सॉरी फॉर दैट. चलो दोस्तों, मैं आपका दोस्त ऐश्वर्य पढ़ाता हूँ आपको गेट ईएससी और एसएससी जेई के लिए. आई हैव डन माय एमटेक फ्रॉम आईआईटी दिल्ली in Geotechnical Engineering batch 11-13 and BTech from Jamia College Delhi batch 7-11. 4 times I have qualified GATE with my best AIR 226, and guys, I do have 6+ years of teaching experience and 2 years of industrial experience. These are the subjects which I basically take on Unacademy official YouTube channel, Unacademy special classes, as well as Unacademy Plus. And friends, this is a code AISH10S10 which you can apply before buying any Unacademy Plus subscription in order to avail 10% off. Okay, so by using this code, you will be getting 10% off, and apart from that, you will be able to avail all these benefits, like you will be having daily live classes, crash courses, rank improvement batches are there. So today only from 12 p.m. 12 noon, I'm going to start rank improvement batch on structures. It is running in both the languages, English and Hindi. So we are having here a doubt clearing session, dedicated doubt clearing sessions, and weekly tests are also there. And apart from this, you will be having a very good interface by which you can interact with the educator. Okay, so these all are the benefits of Unacademy Plus subscription. And my dear friend, this code is not only valid for GATE and ESC. You can even apply this code to other various competitive segments for your friends and relatives like SSC JEE, bank engineer exams, IIT JEE, UPSC, civil services, etc. ओके, चलो स्टार्ट करें आज का सेशन भाई. हिमांशु मिल्कानी सर, एक डाउट था. I think Ayush has given the answer. He's right. So there the things were in recorded form, and here I'm live, and here the content is coming as per the student interaction. Okay, चलो start करते हैं. Yes, and before starting, this is a Unacademy Gate C schedule on YouTube. Hydrology, structures, fluid mechanics, environment, geotechnical engineering. So these two subjects I am taking. In geotechnical engineering, I am only considering the fresh part which has been added by GATE. Okay, so Abhishek sir is also taking geotechnical engineering. Babulal sir is taking design of steel structure. Sitish Sachan sir is taking RCC. Sitish Sachan sir is taking RCC. Chetan sir will start engineering mechanics on 21st of September. Okay, so these all are the updates. So now welcome to the lecture number 41. An announcement is that today geotechnical class will be there at 4:30 p.m. and those who have subscribed Unacademy Plus, for them I am starting rank improvement batch at 12 noon. Rank improvement batch on structure analysis. Okay, and just a quick summary. We have completed the slope deflection method. We have finished the slope deflection method, and today we will going to start the moment distribution method. Today we will going to start the moment distribution method. Okay. So guys, yesterday we conducted a test on slope deflection method and your response was very poor. So I don't know what is the reason behind that. So most of you were coming, no doubt, but they are not participating properly. So the highest marks which I got yesterday was very, very poor. Okay. So guys, please do more practice. Treat structure analysis as a mathematical subject and practice more, and then appear for the test. Okay. Then only I will be motivated for creating new and new questions. Is it clear, my dear friends? So now start moment distribution method. So moment distribution method now is not going to take much time because most of the things are common and we have discussed them already, like how to calculate fixed end moment, what is the carryover moments, what is the stiffness of the beam, depending upon the far end condition. So all those things we have already discussed while I was discussing the introduction to displacement approach. Okay, so now in moment distribution method we have to learn the methodology, we have to learn the distribution theorem and its application. So in 3 to 4 classes I will be able to complete your moment distribution method. And one more good thing on moment distribution method is this. I have already taken a marathon session on this. Marathon session is already there. Those who are watching this video from here onwards, so they can refer to my marathon session on MDM on same channel. Even Abhishek sir has taken a marathon session on moment distribution method last week. So you will be having lot many references here. Okay. Last week only he has taken. Okay. So, and for those students who are completely relying on this video, so for them I'm going to start moment distribution method now. So let's start. So now my dear friends, give the heading distribution theorem. Give the heading distribution theorem. Thanks Geeta. DSS. Amar, क्या है DSS? Design of steel structure. It's already going on. It's already going on. Yes. Follow Chandan Jha. Guys, hit the like button for Aishwary sir. Thanks Chandan. कर दिया करो भाई like. So today lot many new names are here. Good morning मेहता जी. Okay. चलो start करते हैं अब. Start करते हैं. See my dear friends. I'm starting in the same manner by which I started in marathon. So distribution theorem. It is a story of 4 persons who are staying in a room. Okay. So they are sharing a common room and they are taking lunch or dinner together. And the capacity of A is taking 2 rotis and B can take 4 rotis, C can take 6 rotis and D can take 8 rotis. So the total number of rotis which they 4 can take together is 20. Is it clear? Okay. Now what is happening? One day, due to some reasons, the available rotis were only 10 in place of 20. The available rotis were only 10 in place of 20. it was only 10 in place of 20. So now tell me, dear friends, what would be the distribution? What would be the distribution? Good morning, Shri. Tell me, my dear friends, what would be the distribution? So all A, B, C, D are going to take rotis in proportionate amount, or D will take 8, or A will take 2, and B and C will remain hungry. So how it's going to be? 1, 2, 3, 4. Ayush is saying 1, 2, 3, 4. Okay, what about others? Is Ayush right? Okay, 1, 2, 3, 4 proportions. Okay, okay. So, my dear friends, what actually you thought in your mind? क्या सोचा था आप लोगों ने ये 1, 2, 3, 4 करने से पहले? This is what I want to know. You know what you did in your mind? कहीं ना कहीं आपने जब ये इसको 1, 2, 3, 4 मुझे बताया तो आपने सोचा कि ए 2 रोटी तब खाता था जब 20 बनती थी, 2 out of 20, and today the available number of rotis are 10. So you did this thing in your mind, 2 by 20 into 10. Okay, somewhere in your mind you did this thing, 2 by 20 into 10, isn't it? Similarly for B, what you did? 4 by 20 into 10, 6 by 20 into 10, and 8 by 20 into 10. Is it clear to all my dear friends? Is it clear to all my dear friends? Tell me. So it is 1, 2, 3, 4. My dear friend, that is all about distribution theorem. That is all about distribution theorem, nothing else. Okay, so what is distribution? Distributed root is 1, 2, 3, 4. If I ask you what is the distribution factor for A, then what will you say? What is the distribution factor of B, for C, for D? Tell me, what is the distribution factor of A? The distribution factor of A is what? 2 by 20. Yes. 4 by 20 for B, 6 by 20 for C, and 8 by 20 for D. So it is that factor by which if you are going to apply the present scenario, you will be getting the actual scenario. Okay, yes, 2 by 20 or 1 by 10. So 2 by 20 is the distribution factor. If I am going to write here, distribution factor for A is 2 by 20. Distribution factor for B is 4 by 20. Similarly, for C, it is 6 by 20. And for D, it is 8 by 20. Isn't it? Okay. So, what is the methodology to get distribution factor? Here you have seen the individual eating capacity of A, and you have seen, so when total number of 20 rotis were available, he was eating 2. So what you say? Individual eating capacity of a person divided by the sum of eating capacity of all the persons which are staying at a place. Okay. Similarly, when it comes to distribution factor of B, it was individual eating capacity of B divided by the sum of eating capacity of all the members staying there. So total if you are saying distribution factor of A, B, C, D, if you are going to add them all, you will be getting 1. If you are not getting 1, it means you have committed a mistake. So the sum of distribution factor available at a joint is equal to 1. So not joint, at a location is equal to 1. For joint we will be transforming it. Okay. So distribution factor, how you are defining for a particular thing. So individual capacity divided by sum of capacities. Okay, So in layman language, you can write distribution factor like this. Okay. So now, my dear friends, I am simply transforming. Okay. It is individual capacity. It is individual capacity. Individual capacity upon sum of capacity. Okay. You don't have to write all these things. Don't worry. Okay. Just listen to me. You don't have to write all these things. So now I'm transforming to. Okay, Harshit. Okay. Okay. So now I'm transforming this roti wali thing समझ लो into the distribution factor theory or distribution theorem. Now come to the structures. Now come to the structures. See, my dear friend. Suppose I'm having a joint here, which is on which four members are joining. Let's say it is first member. Let's say it is second member. Let's say it is the third member, and let's say it is again fourth member. Okay. And name of this joint be O. So it is A, B, it is C, and it is D. Okay. Is it okay? It is visible now, Harshit and Mahima. Is it visible now? Okay. So now, my dear friend, let's say the length of these members be L1, L2, L3, and L4. And let's say their stiffnesses will be E1, I1, E2, I2, E3, I3, and E4, I4. Okay. So this is a scenario. Okay. So now, if I want to know stiffnesses of OA, if I want to write the stiffness of OA, then how can I write stiffness of OA? Tell me, what is the stiffness of OA? Please tell me fast, all of you. What is the stiffness? Yes, 4EI by L. Very good. 4EI by L. Okay, 4E1I1 upon L1. Similarly, write it for OB, OC, and OD. Fast. For OB. Okay, good. And for OC, it is 4. And OD, it is 3. Okay, yes, it is going to be like this. Okay. So you can consider these stiffnesses as the individual eating capacity of a member. Suppose if I ask how much OA can eat, how many rotis it can eat, so you have to say it can eat 4 EI upon L1. Okay, like that. Okay, in normal condition. Okay. So now, my dear friend, if I want to write the distribution factor for member OA, then what should be the methodology? How can I write the distribution factor of OA? So what I told just now, distribution factor of a member is equal to the individual capacity divided by the sum of capacities of all the members which is actually meeting at that joint, isn't it? So yes, if I want to write the distribution factor for member OA, so distribution factor of member OA, then it is equal to stiffnesses of OA divided by the sum of stiffnesses available at a joint. Means stiffness is due to OA plus stiffnesses due to OB plus stiffnesses due to OC plus stiffnesses of due to OD. So in total there were 4 members which were meeting there. So that is why I am going to write these 4 stiffnesses here. Okay, isn't it? So the distribution factor for OA, my dear friend, would be 4EI by L divided by 4EI by L plus 3. Why 3? Because for OB it is 3I by L. 3EI by L plus OC 4EI by L plus OD 3EI by L. Okay, so this is the distribution factor. This is the exact way of calculating distribution factor, or you can write it like this. Like distribution factor of OA is KOA divided by the sum of the stiffnesses available at joint O. Is it clear to all my dear friends or not? Say yes or no. Is it clear to all? Please tell me. Is it clear to all my dear friends? Okay. Okay. Yes. So I am representing this big expression with summation of k. So whenever I am writing summation of k, you have to understand it is equivalent to this. Okay. So I am not going to write all this again and again. So similarly, my dear friend, if I want to write the distribution factor for OB, it is 3EI by L upon sum of the stiffnesses. Similarly, if I want to write distribution factor for OC, it is, and similarly last OD, it is KOD divided by a summation of K. Okay, is it clear to all my dear friends? And yes, obviously, if you are doing the sum of the distribution factor, so you can write here sum of distribution factor at a joint is equal to 1. Okay, suppose you want to do the sum of distribution factor at joint O, then it will be DFOA plus OB plus OC plus OD, and the denominator portion for all these 4 members are same, and numerator will be simply getting added. So the sum of numerator will also be equal to KOA plus KOB plus KOC plus KOD, and if you are going to add them up, you are going to get the value 1. So you can write here the sum of distribution factor available at a joint is equal to 1. So that is the funda here. Is it clear to all my dear friends? Tell me. Is it clear to all? Okay. So one important note here. The sum of distribution factor available at a joint is equal to 1. Okay. So now my main task is, for which I am going to study all these things. If I am going to apply some moment at joint O. Okay. Suppose here OA, OB, OC and OD, let's say it is for example I am saying it is 0.3, let's say it is 0.2, let's say it is 0.3, let's say it is 0.2. Okay, so see, you can see sum is equal to 1, 0.3, 0.2, 0.3, 0.2. Okay, so now my question is, listen to me very carefully. I have assumed this value, okay, 0.3, 0.2, 0.3, 0.2. So now my question is, if I am going to apply a moment of 100 kilonewton meter at joint O, if I am going to apply a moment of 100 kilonewton meter at joint O, then what would be the bifurcations? Then what would be the bifurcations, my dear friends? Tell me. Due to 100 kilonewton meter, what is going to be the bifurcations? How much moment is going to transfer in member OA, OB, OC and OD? Tell me. So जैसे रोटीज बटी थी एज पर द डिस्ट्रीब्यूशन फैक्टर, वैसे ही इस बार मूवमेंट बटेगा एज पर द डिस्ट्रीब्यूशन फैक्टर. वेरी गुड आस्था. ओ ए 30. Okay. OA and OC 30 and OB and OD 20. Yes. So things are very simple here. That what you have to do. So movement delivered to member OA is the total movement into the distribution factor of OA. Similarly, movement transferred to member OB is equal to total movement into the distribution factor of OB. Similarly for OC and similarly for OD. Yes, it is going to be like that. Yes, very good. Very good. Yes. So now if I am going to draw the free body diagram of this, now listen to me. This is important to understand. This is, let's say, a joint O. Okay. These are very infinitely small thicknesses. Just left, just right, just top, just bottom. Okay. And let's say these are the members. This is member OB, I guess. This is member OA. This is member OC. This is member OD. Yes. So you can write it here. O, 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 O. This is A. It is B. It is C. It is D. Okay. So these were fixed. It was also fixed. It was hinged, and it was also hinged. So stiffnesses here were 4EI by L. Let me call it simply KOA. It is KOA. Now you all know how to write KOA, how to write the distribution factor of OA. Stiffnesses here were KOB. It is KOC. It is KOD. And you know how to calculate the distribution factor here. So distribution factor here would be, it is DF OA. It is DF OB. It is DF OC, and it is DF OD. I hope you know now how to calculate DF, OA, OB, OC and OD. Okay. So now my dear friends, if I am going to apply a moment M here, let's say I am applying a clockwise moment M naught, then this M naught is actually all four members are having their right to claim M naught, and in what amount they are going to claim. So they will claim as per their particular distribution factor. So in the very first example by which I have started my class today, so they are the distribution factor for 2 by 20. So when 10 was available, there, so distribution factor for A was 2 by 20. So how you determine the number of rotis there? 2 by 20 out of 10. Okay. Now distribution factors here are known for all these four members OA, OB, OC and OD. So now if I want to know out of this M naught how much is going to transfer to OA, to OB, to OC, to OD, then again you can calculate them as per the distribution factor of OA, OB, OC and OD. Similarly, if I want to write, my dear friend, the distribution factor of OA, then you know it is KOA divided by summation of all these differences. And similarly, now if I want to find the moment carried at O, so the moment carried at O, let's say, is MOA. So how can I write MOA? Please tell me if you are agreeing with me. MOA is going to be equal to distribution factor of OA plus into movement. Similarly, if I want to know what is MOB, then how can I write MOB? So MOB is equal to, it is distribution factor of OB into M naught. Similarly, if I want to write MOC, it is distribution factor of OC into M naught. And yes, if I want to write MOD, then MOD is also equal to distribution factor for OD into M naught. Okay, is it clear to all my dear friends? Tell me. Okay, and this is clockwise. It is also MOB. It is also MOC. MOD. MOC. Is it clear? Tell me. Is it clear to all? Is it clear to all? So I have given KOA as 0.3 and M naught was equal to 100. So 100 into 0.3 is 30. So like that you have answered. Is it clear to all my dear friends? Please let me know if you are having any doubt so far. अरे समझ में आ गया कि नहीं आ गया? Mukesh is saying clear. What about others? Clear. Clear. Okay. Okay. So lot many new names I have seen today. So have you gone through my earlier videos? Swati, Astha, Annadurai, Piyush, okay, started 2-3 days earlier. Shri Joshi. Okay. So guys, have you gone through my earlier videos? Okay, okay, great. ओके चलिए अब आगे बढ़ते हैं फिर चलो ये भी एक इम्पोर्टेंट सी चीज है छोटी सी चीज है बट मोस्ट ऑफ यू मिसेज इट सी सपोज just tell me the distribution factor for all these four members. EI is same for all four members. EI is same and length is also same. EI and L are same for all members. Just tell me the distribution factor, my dear friends. Thanks, Shri Joshi. Thanks. फ्रीक्वेंसी मैच होने वाली बात होती है यही यूट्यूब पे कुछ बच्चे ये भी आते हैं कि सर मजा नहीं आ रहा बेकार पढ़ा रहे हो आप आपको अच्छा लग रहा है इट्स गुड ओके आस्था वेरी गुड द डिस्ट्रीब्यूशन फैक्टर फॉर OD is 0 वेरी गुड आस्था Yes. So distribution factor for OA is equal to 4EI by L. Distribution factor for OD is 3EI by L. Distribution factor for OC, it is OB, sorry, not OD. It is OB. And for OC, it is again 4EI by L. Yes. And OD distribution factor is 0. Okay, I am writing the stiffnesses part. Okay, and stiffnesses of OD is equal to 0. Okay, so based on this, its distribution factor would be 0. So it is 4, 7, 11. So 4 by 11, very good. Very good, Shubham. Ayush, good. 3 by 11. 4 by 11. Yes, very good. Okay. Now tell me for this scenario. Again EI and L is same for all these four members. EI and L is same for all these four members. Now guys, tell me the distribution factor for OA, OB, OC and OD. Fast. EI and L is same for all four. Akash, you are saying 3 by 8. For what? 3 by 8? No. It is 3 by 11, my dear friend. It is 3 by 11 only. Not 3 by 8. Very good, Shubham. Very good, Shubham. Very good. OA and OC, you are saying it is 4 by 11. No. अच्छा आयुष, कोई बात नहीं. Yes, Mukesh, Shubham right. Piyush right. भाई मेरे को ऐसे सोचना है कि चल क्या रहा है. अगर मैं इस पे यहाँ पे कोई मोमेंट लगाऊंगा, then due to that it is free to rotate in the translation direction like this hinge. So no retaliation, no prevention will be there. So if no retaliation or no prevention is there, then how would it is going to produce the internal forces? Okay, so it is just you can say in spite of being this in support, it is equivalent to this free end, as this free end is free to rotate in this direction in a same manner, in a similar manner. So this joint, B joint, is also able to rotate freely in the vertical direction. So no resistance for the applied moment in this direction. So that's why its stiffness is going to be equal to 0. So this is 0, this is 0, this is 4EI by L, this is again 4EI by L. So now when it comes to the distribution factor, so distribution factor is going to be 0.5, 4 by 8, 0, 0.5, 4 by 8 and 0, isn't it? So it's not about roller hinge or hinge, it's about the orientation. So along this orientation, it is free to rotate. And similarly, my dear friend, I am just changing the question. I hope it is clear to all. I am just changing the question. Suppose D is like this. Suppose D is like this. Now tell me, what is going to be the distribution factor? All of you. Tell my dear friends. E, I and L is same for all. What is going to be the distribution factor? Please tell my dear friends. This one is interesting. Okay, only OB is 0, Piyush is saying. What about others? Four, 4, 3. 4, 0, 4, 3. Okay. Very good. Awesome. Good. See here. Its differences will be 4EI by L. It is 4EI by L. And if we are going to apply moment here, then it is free to rotate in the vertical direction. So stiffnesses will be here 0. It is again 4EI by L. It is 3EI by L. Why it is 3I by L and 0 here? Because it was aligned to rotate it in the vertical direction. And here, due to applied moment, it is not going to go up and down. It will resist some movement. Okay. And here the stiffnesses will be there 3I by L depending upon the far end condition. So in this orientation, this one is equivalent to this one. Okay, but it cannot. It is equivalent to free end. It is equivalent to free end. Okay, so it's not only about the type of support. Here you can see at B and D, types of supports were same. Types of supports were same at B as well as at D. But see, here also it is roller hinge. Here also it is roller hinge. But this roller hinge is having 0 stiffness. But this roller hinge is having 3EI by L. Okay. Yes. Mahima, I am saying that just try to think like this. अगर आपने यहाँ पे कोई मोमेंट लगाया M, तो ये वाला मेंबर बचाएगा मोमेंट, ये वाला मेंबर भी मोमेंट बचाएगा, पर ये आपका सिंपली ऊपर चले जाएगा, बट ये वाला भी मेंबर भी आपका मोमेंट बचाएगा. अगर मैं इसका डिफ्लेक्टेड पैटर्न बनाऊं, अगर मैं आपको इसका डिफ्लेक्टेड पैटर्न इमेजिन करवाऊं ड्यू टू सम मोमेंट M, then it would be like this. It would be like this. Okay, and it would be like this, and it would be like this. So is it understandable? Is it understandable, Mahima? Is it okay, Mahima? So see, no constraints are here. Here the roller support is simply going to translate. Is it clear? So I am saying, in spite of having the similar support condition at B and D, D was able to resist this movement, but B is not. Here B is also roller hinge. Here D is also roller hinge. But it is acting as a hinge support. But it is acting as a free support. Because by providing this roller, there is no benefit of providing this hinge. है ना, एक बार ये रोलर लगा दिया इस डायरेक्शन में, तब तो मूवमेंट लगा के ये ऊपर और नीचे चले जाएगा ना. फिर हिंज वाला एक्शन आएगा कहाँ? हिंज वाला एक्शन तभी पिक्चर में आएगा अगर ये अपनी पोजीशन से डिस्प्लेस नहीं करता, जैसे कि डी, जैसे कि हिंज सपोर्ट. Isn't it? So that is why it is going to act as a linear. It is going to act as a free end here, है ना, because of its orientation. So it's not. वैसे अभी तक ऐसा क्वेश्चन पूछा नहीं है, बट मेरा सॉफ्ट कॉर्नर इस क्वेश्चन की तरफ मुझे लगता है कि जल्दी ये क्वेश्चन गेट में पूछा जाएगा, क्योंकि बच्चे याद कर लेते हैं कि हिंज सपोर्ट है तो 3i by l लगा लो, रोलर भी है तो 3ei by l लगा लो, फ्री है तो फ्री 0 लगा दो, ठीक है. But roller hinge can also be become free if its orientation is changing by 90 degree. Okay, so this is a very important concept and I am expecting soon a question on this. Okay, इज इट क्लियर टू ऑल माय डियर फ्रेंड्स? टेल मी। महिमा आया समझ में आपको? ओके चलो, अब हमें डिस्ट्रीब्यूशन फैक्टर निकालना आ गया। अब हमें फिक्स्ड एंड मूवमेंट निकालना आ गया, वो तो हम पहले ही सीख चुके हैं। फिक्स्ड एंड मूवमेंट है ना, अच्छे अच्छे क्वेश्चंस भी कर चुके हैं उसके ऊपर। फिक्स्ड एंड मूवमेंट निकालना आ गया, डिस्ट्रीब्यूशन थ्योरम आ गई, अब रह गया बस एनालिसिस। ओके, तो पहले हम करेंगे एनालिसिस ऑफ बीम। आज बीम का कराता हूं, कल फ्रेम का कराऊंगा, ठीक है, और परसों भी फ्रेम चलेगा, फिर उसके बाद स्वे एनालिसिस, ठीक है। सो बेसिकली आज 7 है, so by 10th of September I am trying to complete moment distribution method। मुझे लगता है जल्दी हो जाना चाहिए क्योंकि काफी चीजें कॉमन जो थी वो कवर हो गई। फिर 3 days I am going to take for trusses up to 13th of September। फिर उसके बाद 3 दिन लूंगा ILD पे और 4 दिन लूंगा मैं आपका मैट्रिक्स मेथड, और एक आधा सेशन केबल पे लेता हूं, है ना। इज इट क्लियर? यस यस महिमा, यू कैन थिंक लाइक दैट। अगर देखो फ्री होता तब भी देखो ट्रांसलेशन हो गया। आपने ये देखना है ना कि स्टिफनेस इज आ क्यों रही है। स्टिफनेस इज रेसिस्टेंस, है ना। स्प्रिंग को दबाते हो, जितना फोर्स लगाते हो उतना स्प्रिंग नहीं दबती, कम दबती है। क्यों? क्योंकि उसके अंदर स्टिफनेस है। सिमिलरली इफ इट इज लाइक दिस and you are applying here some angle theta, so why the moments are generating here? Because it is not able to rotate here, so this fixed support is applying some moment. Okay, similarly if the scenario is like this and now you are applying some rotation here, still y movement will be there, स्टिल वाई मूवमेंट इज देयर, क्योंकि अगर आप थीटा लगा रहे हो तो अभी भी ये अपनी पोजीशन से ऊपर नीचे नहीं हो पा रहा महिमा, ध्यान से देखो, इसलिए यहाँ पे भी कुछ ना कुछ मूवमेंट्स लगाने पड़ रहे हैं आपको। बट अगर मैं इसको ऐसा कर दूं समथिंग लाइक दिस, नाउ इफ यू आर रोटेटिंग इट, टेल मी, तो क्या ये ऊपर नीचे जाएगा? yes it will go, it will show rigid body behavior, it is not going to show your elastic deformations and all. So internal movements will be producing only when there will be a generation of elastic curve like this, like this, not like this. Here the motion would be rigid body motion. Okay, and similarly my dear friend, if it would have been like this, so now you can decipher it from your common sense. If you are going to apply a moment m or a rotation theta, then that theta is also going to be a rigid body motion. So no retaliation. So it is equivalent to free end. It is equivalent to free end महिमा. Is it clear? हाँ जी पीयूष भाई साहब, लगे तो हुए, कवर करवाने हो ही जाएगा, टेंशन मत लो, है ना। करवाएंगे, जब स्टार्ट किया तो खत्म भी करवाएंगे। ओके चलो, now seeing the analysis part. Analysis very important. ओके सो पहले एक बेसिक से ट्राई करूंगा क्वेश्चन करना, ठीक है, फिर हम उसको सीखेंगे। द important portion is how to calculate the distribution factor, how to calculate the distribution factor. Second, how to calculate the fixed end moment. Okay, then applying distribution theorem, applying the distribution. So these three things will be more than enough. These three things will be more than enough, okay, to analyze your structures. Okay, just give me a minute. My device has been discharged, so let me put it in the charging. Just a minute. Sorry for the interruption. Okay. So I will explain this now by taking an example. Okay. My dear friend, even if you know the procedure, then listen to me very, very carefully. I'm quite sure you will be getting something new here. Okay. Because most of us know how to do movement distribution method, but they do not know what is actually going on in between. Okay. So we will see that first of all. And one more thing, my dear friend, after calculating the end moments, I'm not going to draw bending moment diagram. Okay, because it is the same as that of slope deflection method. स्लोप डिफ्लेक्शन मेथड में भी आप एंड मोमेंट्स निकालते थे. मोमेंट डिस्ट्रीब्यूशन मेथड में भी यू आर गोइंग टू कैलकुलेट एंड मोमेंट. सो वंस यू नो द वैल्यू ऑफ एंड मोमेंट्स, आफ्टर दैट it will be procedure will be same for calculating the BMD from the shortcut method as well as from the long method. Okay. But yes, if in any of the questions you are thinking that sir it's BMD should be discussed, then I will discuss that BMD, but only on demand. Okay. Sir, in the last question, which last question? Akash, which last question you are talking about? I do not know. Okay. Is it regarding my last lecture? Okay, let me explain this, Akash. जिसमें रोलर दिया था इसमें, yes my dear friend, theta would be same. You can calculate theta here, you can calculate theta here, you can calculate theta here. So theta has to be same. If a joint is rigid, so theta has to be same. uh, Good book for practice is your Ramamurthan. So n numbers of questions are there. Okay, very good book, Ramamurthan, for practicing. And if BC Punmiya is there, still it is fine. But the quantity of questions and the varieties of questions are large, are more in Ramamurthan. Okay. Yes. So Akash, yeah, theta would be same for this, for this, for this, and for this. So for all these, theta would be same. Okay. But elastic curve will be absent here. Elastic curve will be absent here. Okay. Is it clear? देखो ना, इसको फील भी कर सकते हो. अगर आप यहाँ पे इसको रख के किसी तरीके से इसको घुमाओ तो ये कर्वेचर दिखाएगा, यहाँ पे कर्वेचर दिखेगा, यहाँ पे कर्वेचर दिखेगा, बट यहाँ पे नहीं दिखेगा. बट यस, रोटेशन उतना ही होगा रिजिड जॉइंट पे जितना बाकियों का हो रखा है, बिकॉज द जॉइंट हैज टू बी इंटैक्ट. इट इज रिजिड जॉइंट. Okay. So my dear friends, BMD will be discussed only of that question which will be on demand. So by default, I am not going to discuss the BMD. Okay. So it is your, let's say, 80 kilonewton, 80 kilonewton, and let's say it is 12 kilonewton per meter. So it is 4 meter, 4 meter, and let's say it is 10 meter. Okay. Okay, keep it 8 meter. Keep it 8 meter. So A B, C and D. Okay, A, B, C and D. So this is the question here. So now you have to calculate and moment. Okay, so first of all, listen to me very carefully. The very first task which I have to do after seeing the questions on displacement approach is to calculate fixed end moment. And if it is a question from moment distribution method, then also we have to calculate the distribution factor. So the fixed end moment here, M A B, is minus PL by 8 minus PL by 8 minus PL by 8 it is, isn't it? So fixed end moment is minus 80, anti-clockwise 80. Okay, and similarly MFBA is PL by 8 clockwise 80. It is clockwise 80. Similarly, if I am calculating the fixed end moment for MFBC and FCB, so MFBC is equal to how much? Minus WL square by 12. So minus 64. And similarly, MFCB is equal to 12. So these values are going to be, let me write here, MFAB is equal to minus 80, MFBA is equal to plus 80, MFBC is equal to minus 64, okay. So these are clear. This must be clear to you. Okay. So any doubt so far? Now next task is to calculate the distribution factor. See how you are going to calculate distribution factor. First of all, you will write joint. After that, you are going to write member. Then after that, you will write stiffnesses, joint, member. After that, you have to write stiffnesses. After that, you have to write summation of stiffnesses. After that, you have to write distribution factor. Okay. So joint, member, stiffnesses. This table you have to use for calculating distribution factor. So it is B, joint, why I am considering only B? Because we will be doing distribution only there where more than one participants are involved, है ना? बंटवारा वही होगा जहां पे एक से ज्यादा लोग होंगे. जहां एक लोग है वहां तो सारा का सारा सामान उसे एक का ही है. क्लियर है कि नहीं है? So at joint B we are having two members, BA and BC, so that is why we are going to distribute the things there. So that is why I am considering only joint B for the distribution. So at joint B, how many members are there? It is member BA and it is member BC. Yes, very good, Akash. So stiffnesses here would be 4 EI by L. Why 4 EI by L? Because the far end is fixed here, the far end is fixed here, and many of you are thinking, sir, B is not fixed. Then how can you write 4 EI by L? So B is not going to rotate in its vertical direction. So whenever I am applying any rotation or movement here, so for this the far end will be treated as A. For this the far end will be treated as C. So conditions would be equivalent to this. If I'm going to rotate it by theta, so stiffnesses will be 4EI by L. Is it clear to all my dear friends? Okay. So now see here, 4EI by L. What about L? L is here 8 meter. Similarly, 4EI by L, L is again here 8 meter. So stiffness is 0.5 EI and 0.5 EI. And if I am calculating the sum of stiffnesses, then this sum is nothing but EI. So now the distribution factor is 4 by 8 and 4 by 8 means 0.5 and 0.5. Okay. So here only two members were there. So I have taken only two members. Suppose if there would have been 3, 4 or 5 members respectively, then I have to do like this, BA, BC, BD and all. Okay. So here you can see distribution factor for both of these members are 0.5 and 0.5. 0.5 and 0.5. Okay. Now listen to me very carefully. Now listen to me very carefully. Here the fixed end moment was anti-clockwise 80. Here it was clockwise 80. And just right of B, the fixed end moment was minus 64. And it was plus 64. So my dear friends, just listen here. At joint B, we know from joint equilibrium condition that my joint must be in equilibrium. Okay, so the summation of moment at my joint must be equal to 0, but here it is not coming out to be 0. Why it is not coming out to be 0? Because this scenario is not as per the real scenario. You have considered this moment by taking this intermediate support as fixed support, but reality is this intermediate support is not fixed, it is hinge support. So these 80 and these anti-clockwise 64 as per the fixed end condition, which is not the real condition. Now I have to convert this wrong value into the correct value. So initially, just to start the analysis, I am considering support B as fixed support. Why I am taking it fixed? Because I am studying displacement method, and in displacement method we have to start the analysis from the kinematically determinate structure, and fixed beam is the only beam which is kinematically planar structure. So that is why initially I have considered joint B as fixed support, and due to these were the moments. But this is not the fact, this is not the truth, my dear friends. So I have to convert this value in such a way that the net moment at B must be equal to 0. So if I ask you what is the net unbalancing at B, what is the net unbalancing at B along with this direction, please tell me. Please tell me how much unbalanced movement is there at B, my dear friend, and what is its direction. Please tell me these things, all of you. Clockwise 16, Harshit. Okay, what about others? Clockwise 16, Ayush is also saying 16, Harshit is saying 16. Clockwise, okay. Mahima is also saying 60 clock, okay. 16 clock. Yeah, correct. Since you can see, just left of B, it is clockwise 80. Just right of B, it is anti-clockwise 64. Okay, it is anti-clockwise 64. So in order to balance it, what I have to do, I have to apply an equal and opposite movement at B. Suppose here the unbalancing is of 16 clockwise. So by default plus is clockwise and negative is anti-clockwise. So if I am writing only 16, it means it is clockwise 16. Okay. So this is the unbalancing. So in order to balance it, what I have to do? I have to apply this 16 in the anti-clockwise direction so that I can make net moment at B is equal to 0. So whenever I'm applying this 16 in the anti-clockwise direction, it means net moment at B is equal to 0. But again, my dear friend, this 16 I'm applying on joint, not on the members. Okay, so whenever I'm going to divide this 16 anti-clockwise to the members, then the division will be done as per the distribution factor of member BA and of member BC. And the distribution factor of member BA and BC are same, which is equal to 0.5 and 0.5 respectively. So this minus 16 or anti-clockwise 16 is going to have its two components, minus 8 and minus 8. So it is 0.5 times of minus 16 is minus 8. It is again 0.5 times of minus 16 is minus 8. Is it clear to all my dear friends? Is it clear to all my dear friends? Tell me. Is it clear to all my dear friends? Okay. So this minus 8 and this minus 8 will be the component of member BA and BC respectively, and the far end for A, far end for BA is fixed, and the far end for BC is also fixed, and whenever I am having far end as fixed support, then the carryover moment is equal to half. So carryover moment is equal to half. So it is minus 4 and it is also minus 4. Okay. So now my dear friend, task is over. Now the thing is done. Now the task is over. Just see the final values. So net moment at A, anti-clockwise 80, anti-clockwise 4 is 84. It is 72. 80 minus 8, minus 64 minus 8 minus 72. It is 60. So these are, now you can see the net balancing. Net unbalancing at B is 0. So plus 72 minus 72 is equal to 0. So it is minus 84, 0 and 60. Is it clear to all my dear friends? Tell me. Is it clear to all? So these are the final end moments, and after that you know how to plot the end moment diagram. After that you know how to plot the end moment diagram. Is it clear to all my dear friends? Is it okay? Okay. So now my dear friend, how you are going to tabulate it? How you are going to tabulate it? This is important to know. See, so this is one way of writing, and similarly what I am doing here. So see, joint, joint, just a minute. Joints are how many here? A, B and C. Okay, what about members? Members are at A only one member AB, at B there are two members B and BC, at C there is only one member CB, and distribution factor. So here distribution cannot be done. Here the distribution factor is 0.5 and 0.5, and here it is nothing. So that's all. Okay. So now see my dear friends. So in order to start, I have to write here the fixed end moments. Fixed end moment it is minus 80 plus 80 minus 64 plus 64, and the distribution is required here. So the next step I am going to write is of distribution. So distribution will be required at joint B. So total unbalancing is of 16 clockwise. So minus 16 is to be distributed into 0.5. So minus 8 and minus 8. So whatever you have remembered so far, that this and this is plus, so apply minus and distribute into half. So minus 8 minus 8. And now the carryover is there. Now the carryover is there. So carryover would be half, because far end is fixed. Here as well the far end is fixed, so it would be half. And now you can see as no unbalancing is available at B, so now you can calculate the final end moments, and the final end moments would be final end moment it would be minus 84, 72, minus 72 and 60. Is it clear to all my dear friends? Tell me. So this is the very simple funda on the moment distribution method. Please let me know guys if you are having any doubts so far, then we can discuss them in detail. Okay. Yes, अगर सी फिक्स सपोर्ट हो तो कैरी ओवर जीरो होगा, फिक्स हो तो हाफ. बिल्कुल, डोंट वरी आयुष. ये भी तो पहला क्वेश्चन है. आई एम गोइंग टू कवर ऑल दोज वेराइटीज, डोंट वरी फॉर दैट. First of all, only let me know whatever I have taught you, is it clear to you or not? So we will see what will be happening to see if it would have been hinge by both the methods, by considering that as hinge as well as by fixed. We will see that. Don't worry for that. So there is a very delicate line, I will tell you, that how to tackle such questions. Okay, is it clear to all my dear friends? Okay, great. Okay friends, then we will be continuing this session tomorrow. Okay, and I will be taking some more varieties question, and then after that I will be shifting to frames. Okay, is it clear? And my dear friend, moment distribution method is one of the favorite method of gate, because lot many thinking is required here. So gate basically put focus on such method in which thinking is required. Okay, is it clear to all my dear friends? So let us meet tomorrow at morning is 10 a.m. and meet me for geotech at evening 4:30. Okay, so only 3-4 sessions more on geotech. So today I will finish laterally loaded pile, and then I will be starting the pile group efficiencies. Okay, slope B की direction बताइए. Okay, slope B की direction बताना is not a big deal here. Okay, so what you have to do, you know it is minus 72. Okay, so just see MBC, you know it is 2EI by L 2 theta B minus what was the fixed end moment? 64. So MBC is minus 72. It is 4EI by 8 theta B minus 64. So it is minus 64, it is plus 72. So it is minus 8 EI theta B by 2. So theta B is minus 16 upon EI. So it is anti-clockwise 16 upon EI, Mukesh. Is it clear? Is it clear, Mukesh? Is it clear? Okay, so let's keep the session up to here only, and we will be meeting again tomorrow at 10 a.m. and for geotechnical I will be meeting you guys at 4:30 p.m. Okay, and any of my friend if it is interested in an Academy Plus subscription, then you can download the Unacademy's learner app, and from there you can pick the course GATE and ESC, and after that you can apply subscription by using my code S10, and if you are going to use this code, then directly you will be getting the 10% off on your Unacademy Plus subscription. Is it clear? Okay. And the benefits of Unacademy Plus subscription, it is having daily live classes, weekend batches are there, weekend tests are there, rank improvement batches are there, crash courses are there, interaction with the faculty is there, courses are running on the bi-language English as well as on Hindi languages. Okay, is it clear to all? And my dear friends, this code is applicable not only for GATE and ESE, it is also applicable for various other competitive exams. If any of your friend or relative is in need of Unacademy Plus subscription, then consider this code as a universal code and you can apply this code on each and every segment offered by Unacademy. Is it clear? AISH10, very easy code to remember. Okay. And this is our Facebook page, and this is our Telegram channel. If you are not a part of this, then please you can subscribe this channel. And these are the various Unacademy channel offered by Unacademy Plus, Unacademy only. So right now you all are watching here. If you have not subscribed this channel yet, then please do subscribe and welcome us. So thank you, my dear friends. Thanks a lot. Thank you. Have a nice day. Stay safe. Don't go outside if it is not required. Have fun. Great. Enjoy.